In this video, we're going to be doing a restoration on this beautiful motor, which was manufactured by the Holtzer-Cabot company out of Massachusetts. This company was in business from approximately 1875 until about 1972. They made a variety of products. They made some parts for telegraphs, they made some parts for fire alarm systems, and they made a lot of high quality motors. Many of their small pancake style motors, similar to this one, were used in player pianos. And they also manufactured some of the most highly sought after antique fans that were ever built. Some of their early fans, such as the basket weave and the tombstone, those are some of the most rare fans that you can find if you're into antique fans. Anyways, their motors were very high quality, and I've actually had this motor for a while, and I've kind of neglected it. I've never taken it apart or cleaned it. I just put a little oil on it, and I've been using it. And I actually showed this briefly in the video where I restored the Betts, the little round motor. Anyways, this motor is a 6-pole, so it runs at 1200 RPMs, and it's a 1/6 of a horsepower. This is like a utility motor, and it wasn't really meant to go inside of a player piano. It just has the regular bass on it. Anyways, what I use this motor for is I use it to drive this carding wheel. And these carding wheels is a type of a wire wheel with an extremely fine wire. It's almost the equivalent of taking a piece of 4/0 steel wool and powering it with an electric motor. It really comes in handy when you're doing these restoration projects, and they use it quite frequently in gunsmithing restorations. So anyways, we're going to take this motor apart, and we're going to see what the problem is with it, because what's happening is I have to either give the motor a whack or I have to turn the shaft to get it going. One of the problems that the motor has is that the shaft has entirely too much end play. So this style of motor actually utilizes carbon brushes back here, and because there's so much end play in the shaft, the contacts are not making a connection with the carbon brushes. It also appears that the centrifugal switch is either dirty or it's broken or something, because it's not kicking in and out the way that it's supposed to. So once we get it torn apart, we'll figure out what's going on with it and give it a complete restoration. So I think that you're going to enjoy following along on the restoration of this beautiful piece. So we've run into our first complication, and that complication is that this bolt right here is snapped off, and that was snapped off before we started. We didn't break it while we were doing the disassembly. Anyways, this bolt secures this terminal into position. So what I'll try to do is I'm going to try to use a left-handed drill bit and see if I can get that out of there. But for right now, what I'm going to do is I'm just going to cut this right here, because we will be replacing these wires anyway. So I'll cut that, and that'll allow me to disassemble the rest of this, and then later on we'll use the left-handed drill bit and see if we can get that broken bolt out of there. So we were successful in getting that broken bolt drilled out of there. It was kind of a delicate operation, but we did it without damaging anything.
Okay, so we have all the wiring out and we have everything tagged so that we remember where it goes when we put this thing back together. The next thing that I'm going to try to do is I am going to try to remove this stator. And this stator is very reminiscent of the Century Invincible motor that I did, in that you could only remove the stator from the one side. So in order to remove it, I'm going to carefully use a drift, and I'm going to tap around on these bolts right here and see if I could just persuade it out of there. It's just press fit in there. If I have to get into using a torch to expand the housing, I'll do that. Sometimes you can put these in the freezer and actually let the stator contract a little bit, then heat the outside with a torch and let that expand. But I think that this thing is pressed in there lightly enough that we'll just be able to tap it out. So that's going to be the next step. Be real careful not to break anything. So right now what I'm doing is a couple of resistance tests on the windings. I have the megger out and the meter, and right now I'm checking the resistance on the start windings. And the start windings are always going to have a little bit of a higher resistance reading than the run windings because it's a thinner wire and there's less turns of wire. So it's normal for that resistance value to be several times higher than the resistance value for the run windings. Anyways, I measured these, and the measure value on the windings right now is about 8 megohms, which is a little bit low. I feel confident that that reading is going to come up once we get these windings cleaned and dried out. So, but it's acceptable for right now. But I do feel confident that we can get it a little bit better. So, anyways, we know that the windings don't have any fatal damage to them. So the issue with the starting must be inside the centrifugal switch. Okay, so now I've gone ahead and I've cleaned up all the windings, and they weren't in too bad a condition, so it didn't take a real long time to get those cleaned up. And now the next part is we're going to start replacing these lead wires coming off of here. And the wires coming off those start windings, that's a very thin wire, and those wires are really delicate. So you want to be careful not to bend those back and forth unnecessarily, because if it snaps off, then you create a lot bigger problem. So we're carefully going to replace and repair those, and we'll bring you guys back. What I'm doing now is I'm very, very carefully cutting these bands so that I can expose a little bit more of this lead wire here. This is for the start winding, and that way I can repair the wire going back further into the junction here. So it's a very delicate job, but in the end it results in a better repair. So we'll take our time and do a thorough job on this. I had the stator sitting in a heating pad for a few hours just to make sure that those windings were warm and dry before applying the insulating varnish. And I went ahead and I applied 2 coats of this EL600 made by Spray-On. I've been real happy with this product. So the next step will be to take the space heater and just to keep that on the stator for a little bit, make sure that that insulating varnish dries thoroughly. While I was in here, I also took some friction tape and I just tightened up a couple areas where the start windings were hanging out there a little bit precariously. So right now, the stator should be good to go. Alright, so I got the end bells and I got the hardware soaking in some purple power. And I've mentioned before, I'm a big fan of this product. Works good for stripping paint, things like that. Just soak the pieces in there and come back in a day or so and everything will be cleaned and all the paint will be removed. Alright, so here you can see the centrifugal switch mechanism inside this motor. And just by looking at it, one thing I could see is that that spring is heavily corroded. So I'm sure that that corrosion is impeding the action on the switch. So the way that the switch is supposed to work is as the motor reaches its RPMs here, the centrifugal force opens that, and that breaks this contact between this and this. The one thing I could see is that this doesn't want to close all the way in there. It doesn't want to seat in there all the way, and I think that's because of the corrosion on the spring. The second thing that I can see just by looking in there, I know it's a little difficult to see with the camera, is that that contact is loaded up with grease and dirt. So that needs to be cleaned because those need to make an electrical connection in there. So we'll start by taking this thing apart and completely degreasing everything and removing the corrosion from that spring, and I'm pretty confident that that's going to help out our situation quite a bit. So I got the switch cleaned up a little bit, and I paid particular attention to this contact area in between here. And I think the main problem we were having with this switch, now that I'm looking at it a little bit closer, is right here. If you look here, this should positively close on here. This should be in there nice and tight. And so that adjustment is made via these two nuts right here. So I'm going to tighten those down a little bit, which will give this a more positive closure when that snaps back into position. Because I think what was happening before between the dirt and the grease is that this was coming down here like this, but it wasn't really engaging in there the way it should. So we'll tighten the pressure on those a little bit, and hopefully that's going to fix our problem. When I go to put this thing back together, I'm going to change that thrust washer that was on there. That was the only one that was on there, and I mentioned before that this rotor, to me, it seems like it has too much play. So first we'll replace that one, and additionally I'm going to add a second one on this side and hopefully push that rotor a little bit closer to the brushes. And then if it needs another one, I have another one here on standby. So we'll start off with the two of them, and then we'll test out the motor, and if it needs another one, we'll add it. Sometimes it's a little bit of a guessing game with these thrust washers, especially when the original ones are missing. Okay, so because the original nickel plating on these pieces was so corroded and pitted, I removed it using some muriatic acid, and then just cleaned up these pieces, and now they're back down to their brass finish. And I didn't shine them to a polish because I intend to weather them a little bit. So I'm going to cheat. I'm going to use a little bit of these chemicals which help to speed up the aging process. And because we're doing that Japan finish on this motor, I think it's better to give the hardware a slightly antique look. So I'm going to go ahead and hit these with a coat of the darkener, and then this one adds like a little bit of the verdigris, the green patina on there. So we're going to hit those with those chemicals, and they'll be ready to go. So the pieces are done, and right now they're still a little bit more weathered than what they're going to be at the end. So what I'm going to do is I'm going to leave them like this for right now. I'll put the motor back together, and then once I got everything back together, I'll lightly touch these up with a little bit of steel wool and just knock a little bit more of that excessive weathering off there, and they'll be good to go. They really look good though. Okay, so for this project, I decided to go ahead and apply a traditional finish known as Japanning. And if you decide to jump off into the pool of Japanning, you'll find that there's an endless variety of formulations and theories that people have on how to get the best finish and what was the traditional finish. And there's really a lot of research that you could do if you were interested into diving off that cliff. But as far as we're concerned, the formulation that I use is this one right in front of you. And the formulation that we're using here is this product called Sennefelder's Liquid Asphaltum, and this is organic boiled linseed oil, and it's a ratio of 70 milliliters to 15 milliliters. Traditionally, Japanning consists of three parts, which is asphaltum, also known as gilsonite, turpentine, and boiled linseed oil. The reason why I like to use this formulation is because the liquid asphaltum already has the asphaltum and the turpentine pre-mixed. So instead of having three variables, you only have two, and that makes it a little bit more difficult to mess things up while you're applying it. So what you do is you mix these up in the ratios, the 70 to 15, and then you apply it with a nice brush that's not going to lose any hairs while you're using it. And then you have to bake this in a series of bakings so that it hardens on. And so what I do is I apply it, then I put it in a toaster oven for about 2 hours at about 200 degrees, let it cool down, and then about 2 more hours at about 385. And after you do that, you should have a nice hard finish with this. And then if you want to put on a second or third coat, usually you want to put on at least 3 coats, you have to repeat the process again. Put on your second coat, do your first baking, let it cool down, do your second baking, and so on and so forth. So needless to say, this is a very time-consuming finish, but it really looks beautiful when it's done. So this is the way that we're going to approach the finish on this motor, and I think that you're going to enjoy checking out the finish when it's done. Okay, so here's the Japanning after I mixed the 2 ingredients, and I let this sit overnight just so that the ingredients could fully dissolve. And I went ahead and I applied 1 coat to the motor, and you can see how that looks. Of course, it's still wet. Now the Japanning is self-leveling, so I'm going to go ahead and just let that set for a little while, maybe 30 minutes or so. And if I notice any major runs or anything like that, at this stage I could still go ahead and smooth those out before I put it in the oven. So I'll let it set up, make sure I don't see any heavy duty runs or anything like that. If I do, I'll smooth them out, and then after about 30 minutes or so, we'll pop it in the oven. Now this Japanning has this beautiful deep, rich, brownish black finish. However, if you're looking for a mirror-like finish, then you're better off just to go ahead and get your pieces powder coated or spray them with a paint and then clear coat them. But this is a beautiful, authentic finish, and it really looks nice. And it's also very durable, much more durable than a regular paint. Traditionally, pieces that were japanned were just dipped into a large vat of the Japanning. They were hung the excess japanning just dripped off, and then they were put in the oven. So a traditional japanning finish does have more imperfections in it than a painted or powder coated finish, but in my opinion it's also more beautiful. So anyways, I'm gonna let this set up and we'll pop it in the oven and see how it comes out. Originally, this motor was lubricated using grease, and a lot of times they actually used to use Vaseline or other petroleum jelly and just put it in here, and as the motor warmed up, it would kind of drip down through the hole in the bottom and lubricate the shaft. But in my opinion, I try to avoid greasing as a lubricant for electric motors whenever possible. I feel that an oil lubricated motor is always better lubricated than grease. Grease has a tendency to dry out over time. It's just not as effective as the oil. So I have a little collection of extra oilers that I've taken off old motors, and my intention, I took these apart right here, and my intention is to use the spring and these wicks right here. So I'll clean those up, and I should be able to hopefully drop these in here and use that without making any major modifications to the motor. So we're going to try to do that and change this to an oil lubricated motor. So I just wanted to demonstrate the difference in the mega reading from when we first started working on the motor to what the mega reading is now. As you saw in that last test there, the mega reading is now at infinity, which is the best reading that you can get. So that just demonstrates the importance of cleaning, drying, and varnishing those windings. Makes an enormous difference.
Okay, so now this project is finished. and I really had a fun time getting this old Holtzer-Cabot motor back in running condition. It's really a beautiful motor. We did a little bit of Japanning in this video, and I tried to preserve the original look and feel of the motor with the exposed terminals there. You know, we re-weathered them after we were finished, and I'm really happy with the way that it came out. It's running good now. It seems like most of the problems that we had with it were in that centrifugal switch. So once we got that clean and adjusted, the rest of it was pretty straightforward. So I hope you enjoyed following along on the restoration of this beautiful motor. Look forward to seeing you the next time. Thank you very much for watching.